So in this video, I'd like to give a bit of an introduction to firewalls, and this is going to be a high-level introduction, and actually specify that when I say firewalls here, I mean kind of the more traditional firewalls, and nowadays firewalls are more sophisticated than they used to be, but I'm talking about the firewalls people talked about literally a couple of decades ago in terms of functionality and security provided, and there was a time actually when firewalls together with, let's say, anti-malware software were the only two things most people really needed to provide an adequate level of security on their networks. I think that's no longer the case today. You do need a lot more because of attacks and how they've evolved. But I want to talk about kind of one of the original building blocks of a typical network security stack. So the way that a firewall typically works is imagine you've got let's say the internet. Okay, draw the internet as a cloud, and we'll write the word internet here so you know that I'm referring to the internet. Okay, and this is kind of the world at large, and maybe behind the internet, maybe there's a corporation here, and they have their own network. So make a nice big corporation. They've got their own network. They have a bunch of systems in their network, and the idea is that these systems are communicating via the internet, and they may be communicating to some other systems that are located on, as part of the internet on some other domain or maybe some other part of the internet address space. And there's data being sent back and forth, and this data is typically being sent in the form of packets. And so you'd have a packet of data, gets transmitted and gets received by the enterprise or by some corporation or by some network. It could be a school or a company or a government or what have you. And really back and forth communication is taking place. Now, what a firewall will typically do is a firewall will look at this packet, but it'll only look at a specific number of attributes, very, very specific attributes of this packet. So what are those attributes that are relevant in the context of a firewall? Well, the things that we're going to look for are what's called a source address, the source, and this is typically an IP address, which is the Internet Protocol address. It specifies where that system is located on the internet. It'll look at the destination, in other words, where is that packet going to? Okay, and that's also an IP address as well. And then it'll also look at the actual protocol being used for communication, the protocol. Now, in the case of protocols like TCP and UDP, which are two very popular protocols, in addition, you'll also have to consider, the firewall will typically consider the port associated with that protocol. And because TCP and UDP are so popular and their ports tend to have very well-defined uses, you really do need to look at the port number to kind of find out what that traffic is about. And actually, let me give you some examples here. So it turns out that, for example, the simple mail transfer protocol, SMTP, always goes over port 25. And then people who are more old school will remember kind of telnetting to port 25 and being able to forge email that way and things of that nature. But SMTP is the protocol the port that's used, or 25 rather, is the port that's typically used for SMTP. HTTP, which governs all the kind of traffic on the web, anything your browser is emanating if it's not secured, typically will go over port 80. If you're talking about SSL traffic, or what's referred to as HTTPS, that goes over port 43. Let me give a couple more examples to make this more complete. Telnet, a popular old application, I believe that goes over port 23. And how about just maybe one more example, SSH, which is Secure Shell. And Secure Shell, what port? I think it goes over port 22. Okay, so basically these are the different ports that are used with these different applications. Okay, and then what would typically happen is by looking at the source IP address, the destination IP address, and the protocol and the port as well, the firewall would basically would look at a rules table. So you can imagine here's the firewall and it's kind of residing right here. Okay, and it would examine the content packets. It's particularly would look for this header information and then look this header information up in a table. And the table might say, for example, maybe it'll say that anything over, let's say, port 23 should be blocked. Okay? And that would mean that if you were to do that, then that would mean that you wouldn't be allowing any telnet communication to happen to the enterprise or to whatever hosts are behind this particular firewall. And that's actually a popular a popular rule type that exists in many firewalls in practice because most people do not like to use Telnet anymore to connect to different systems. Telnet was a popular vehicle, a popular protocol for connecting to remote systems quite a while back. I would say, maybe a decade or two ago. Nowadays, typically people use protocols like SSH to connect to a remote host because SSH is encrypted, whereas Telnet, all that traffic would go in the clear. Okay, and so nowadays enterprises do not want to allow any type of Telnet access, and if they do see Telnet access, it's likely somebody who's trying to infiltrate the network, and so by default, they will blanket block all Telnet instances. Okay, now the way I've described this here, this particular notion of looking at these three pieces of the packet, these are what were called packet filter firewalls. So they're kind of the original traditional firewalls. Okay. Another variation on theme is something called the stateful filter. Okay, so stateful filter would look at more than just a single packet. The idea behind a packet filter was to look at 4 attributes, or 3 attributes rather, from a packet. The stateful filter is going to look at more than just those 3 attributes. What it's going to do is it's going to look at those attributes across multiple packets. So imagine you've got now not just one packet, imagine you've got multiple packets that are being sent. Okay? And typically, a network flow will have multiple packets associated with it. One packet is rarely sent in isolation without any other supporting packets that might be sent either before or after it. And a typical flow will have multiple packets. And the idea behind a stateful filter is to look at these types of attributes, but look at them across multiple packets, not just a single packet, but multiple packets. Okay, and then make a decision based on that. And obviously, the challenge here, the big challenge in being able to implement the stateful filter effectively is going to be performance, and obviously if you have to keep track of multiple packets and track of state and track of flow, you're going to get a degradation in performance, and obviously the hope is to get more security as a trade-off for that performance, but it definitely is a bit of a performance hit. Okay, now this is kind of how firewalls work. This is kind of Firewalls 101. The big challenge with firewalls, as you might have guessed, is that nowadays there's really no, maybe the best way to phrase it is that there's no application awareness. No application awareness. In other words, all firewalls today really just look purely at these high-level attributes, things like source and destination and protocol. They don't think about what application might be generating that traffic. And you might have like a web browser involved. Maybe there's a communications application, instant messaging application, peer-to-peer file sharing. All of the above. I mean, let's say peer-to-peer file sharing and IM may both be going over HTTP, and maybe you don't want to allow that particular peer-to-peer protocol or that particular peer-to-peer application within your network, but there's no way to do it currently, no way to block it at the firewall level because the firewall rules are too coarse. They're very, very coarse rules. They look at very, very high-level attributes, and they don't provide the ability to maybe go and drill a level deeper, and that's really what's required of network security today. So I'm going to stop this video here. In future videos, I'll talk more about how you can get around this problem, and in many ways how firewalls have evolved to be able to address some of these types of issues.